Hello everyone, welcome to our little show. My name is Heinrich Hertz. Yes, the unit of frequency, Hertz. Back in the 1880s, I chased invisible waves, radio waves, just as Maxwell predicted. I built a spark transmitter and, across the room, a loop with a tiny gap as receiver. If waves were real, a spark should appear at the receiver. And it did. Simple, elegant, and in the dark. Sparks flew and proved electromagnetic waves exist. Then I tinkered. I boxed the receiver to see the tiny spark more clearly. Strangely, inside the box the spark weakened. Uncover it. Strong again. After experiments I found the culprit. Ultraviolet light from the big spark helped the small spark jump. I wrote it as a peculiar side effect, the photoelectric effect. A tiny anomaly that would change physics. Isn't science neat? Greetings. I am Philip Lenard, picking up where Hertz left off. I sealed a metal plate inside a vacuum tube and shone ultraviolet light on it. Something flew off the metal when the light hit. Tiny particles. With electric fields, I proved they were electrons. Photoelectrons. Think of light as wind and electrons as dust being blown off. Light knocks electrons out. The photoelectric effect. I increased the intensity, expecting faster, more energetic electrons. More electrons came off. But their energy did not increase. Brighter light gave more electrons, not faster ones. Completely baffling. Then I changed the light's color. Its frequency. Red light, no electrons. No matter how bright. Cross a threshold frequency and electrons pop out, faster at higher frequency. Hello there. I am Albert Einstein. Leonard's puzzle suggested we were missing something about light itself. What if light is not continuous, but tiny packets of energy? Like water balloons rather than a steady hose. Discrete quanta. I called them light quanta. Today you call them photons. A photon's energy is set by its frequency, its color. Blue photons carry more energy. Red photons carry less. An electron must pay a ticket, the work function, to escape the metal. Many red photons can't combine. One high-frequency photon can knock it free. The electron's kinetic energy equals photon energy minus the work function. Light is both wave and particle. A profound change in physics. First puzzle. Brighter light did not make electrons faster. Brighter means more photons per second. Not more energy per photon. So you get more electrons, but the maximum energy stays the same. It is a one photon, one electron interaction. A high-frequency photon is like a dollar bill, enough to buy escape. Low-frequency coins aren't. Excess energy becomes the electron's kinetic energy. It's change. My theory predicts a straight line. Electron energy rises linearly with frequency. This dual nature launched quantum mechanics, a new way to see the universe. We imagined waves shaking electrons until they flew out. Brighter waves should shake harder. Dim light should take time. But brighter light did not give faster electrons, and there was no delay. With the right color, electrons came out instantly, even at the dimmest light. Not a slow build-up, but a single sharp hit. A particle-like event. One photon, one electron. If the photon has enough energy, bam! It was radical. Light diffracts and interferes like a wave, yet acts as particles too. We needed precise measurements to test Einstein's linear prediction.
My turn. Robert Millikan at your service, and a skeptic of light quanta. I built a machine shop in vacuum, a rotating wheel of clean metal samples. Each surface was scraped pristine seconds before measurement. I illuminated with a single, pure frequency every run. A reverse voltage, like a hill, pushed back until even the fastest were stopped. That stopping voltage measured the electron's maximum energy. I repeated across colors and metals, systematically. Thousands of hours over 10 years, frequency versus energy logged meticulously. If waves were right, messy curves. If photons were right, a straight line. Einstein said the slope should be Planck's constant. I was betting against him, but the data would decide. I plotted the results. Frequency on the horizontal, maximum electron energy vertical. A stunning picture emerged, a beautiful straight line. The slope matched Planck's constant with remarkable accuracy. My heart sank as a skeptic but soared as a scientist. Electron energy was directly proportional to light frequency. Precise, unambiguous confirmation. The evidence was overwhelming.
His measurements elevated light quanta from hypothesis to fact, a cornerstone of quantum theory. My tiny spark in light note became a gateway to new physics. Always chase anomalies. They hide profound truths. Energy comes in quanta. A fundamental statement about nature.
Rigor and loyalty to evidence matter more than intuition.
Digital cameras, solar panels, even door sensors harness the photoelectric effect. From labs to daily life, this discovery powers our world. Science advances as a chain of discovery across generations.
I noticed a spark that changed with light. I found electrons were being ejected. I proposed photons. I measured and confirmed.
Light behaves as both wave and particle, a cornerstone of quantum mechanics. Welcome to a universe of probabilities and quantum leaps. It all began with a simple, unexpected spark. Thank you for watching. Consider the world around you. Science is everywhere.